All right, Algebra 1, welcome to February. And in February, we will say goodbye to exponential functions, although it was a lot of fun. But it's going to take us a while. We need to talk about quadratics, polynomials, things like that. Okay, so a lot of vocabulary and some new kind of stuff. So pay attention and write down all the new words and their definitions, the definitions in your own words. So let's start. Polynomial. First word, polynomial. That means many. Poly means many, and nomial is a fun word for terms, which are the things separated by plus and minus signs. Okay, so I'm just gonna. So like all of these have three terms, and I'm underlining the terms. Okay, fifth degree. The degree is the highest exponent. You know, look for the term with the highest exponent. That exponent is called the degree. So write down degree, highest exponent. Leading coefficient. That, now you know what a coefficient is, right? The number multiplied by the variable. It's the coefficient of term with the degree. All right. And a constant term, that's the term without a variable, aka the y-intercept. All right. All right, so we want a fifth degree. So first of all, that's a sixth degree. Sorry, you gotta go. This is a seventh degree. Okay, so these two are fifth degrees, A and D. Now, which one has a leading coefficient of 7? It would have to be this, because it's 7. And then the 6 is a constant term, and it all works out, doesn't it? All right, so lots of good vocabulary. Don't move on until you've written it all down. Degree. Hopefully, and then if there's some more vocabulary that you run across, post it in the organizer and we'll cover that too. But that was, oh, standard form. We should probably talk about standard form. Standard form is a polynomial written with exponents in descending order. Example, x squared plus x plus 7. You see, the first term has an exponent of 2, the next one has an exponent of 1, and the last term doesn't even have a variable, which makes that an exponent of 0. All right, moving on. To go let Mr. Johnson in. Okay, so now we're going to talk about multiplying monomials, polynomials, and in that we will also add, but adding is not too bad. We just add the coefficients of the like terms together. So you'll see that. But let's talk about multiplying. So here we have a rectangle. We know the area of a rectangle is base times height. And this top can be our base, top and bottom. And the height is 4. So in this first box, we're going to multiply 4 times x squared. What is 4 times x squared? Guess what? It's just 4x squared. Nothing really to do there. How about this box? We're multiplying 4 times 3x. What is 4 times 3x? 12x. And in this last box, we're multiplying 2 right up here times the 4 all the way over here, which is 8. So our answer, and then our answer is going to be the polynomial where all of those are added together. Unfortunately, all in the same color, like my work. Plus 12x plus 8. You see? So we just add them together. Now this one, I'm not going to do the whole one, but I do want to just say that when we do 2x and 3x, multiply those together. I didn't need to write the dot. What is 2x times 3x? It is 6x squared, because x times x is x squared. And this one would be negative 9x. All right, let's just do that. 6x squared minus 9x. Okay. Moving on. Multiplying binomials area model. So now we can, let's say we have binomials. So usually they're not written, like this. Usually you see them like this. X plus 2, x plus 4. This is how you'll generally see them. And then you can put them into this rectangular model, which I use a lot in class. And you might say, well, this is not useful in real life, but it is. It is. Okay, we're just learning about it. We can put some context behind it, but right now, how would you multiply these things together? Well, just multiply all 4 little squares here. So this is x times x, which is x squared. This is 2 times x, which is, well, this is 2x. This is 4 times x. And this last square is 4 times 2, which is 8. So now, with the other one, we didn't have any like terms. Now we have 2 like terms, the 4x and the 2x. And so we add them together and they add to 6x. So our final answer is the x squared from the first box, 6x, the combination of the 2 linear terms, and then the constant term. Notice I slipped that vocabulary in there. Linear terms is the term with a degree of 1, exponent of 1, plus 8. All right. Okay, Binomials Intro. So this is not going to be any harder because look, see, what we're going to do is we're going to set up a little rectangle figure like this. I make all the boxes the same size. I'm going to put the x plus 3 on top and the x minus 5 to the side. And we'll give the negative to the 5. And then we just multiply. This first box would be x squared. 3 times x is 3x. This box is negative 5 times the x on top. And this last box is negative 5 times 3, which is negative 15. Notice again, like with the last one, we have like terms right here. It's usually in that diagonal. What is negative 5x plus 3x? Negative 2x. So our final answer is x squared minus 2x minus 15. X squared minus 2x minus 15. All right. So that's the multiplying binomials and polynomials, and a little bit of adding and subtracting. And now we're going to do review of functions. Okay, so try this quiz and then watch the answers that I'm about to do afterwards. 5 questions. All right, here we go. Princess Tower, I remember this. So T of 20 equals T of C. In order to do this question, we need to know what 20 represents. 20 is n, and n represents floor n. So this means floor 20. So C means floor C. And what does T of 20 mean? T of n models the number of tenants living on floor n. So this is number of tenants on floor 20. And what do we know? It's equal to the number of tenants on floor C. That's what the equation says. They have the same number of tenants. Range. Okay. How do we find the range? In statistics and in algebra, it's the same. We always find the range the same way. Subtract high minus low. That's all there is to it. So it's the high up. And range is the y value. So we want to subtract the high y, which is 4, minus the low y, which is -3, which is 7. So the range is 7. Oh. All right. You know what? But in algebra, we write it as an inequality. So it goes from -3 to 4. Oh no. -3 to 4. Do you know what? This is a discrete function. I better be more careful. I got too confident. All right. Let's reboot now. I said a lot of stuff that's true, but in this particular function, what we need to do is we need to write down the y coordinates for these points. I apologize. So the range is the y values. And what are the y values represented in this function? -3, we have a output. At -2, we have an output. At 2, we have an output. And at 4. So the first thing that I said is a range, but it's for statistics. The second thing that I said would have been true if it was continuous, if there was a line all the way through. But this one is going to have to be, just those 4 points. Oh, well, you win some, you lose some. Write the formula for h of n in terms of n. So what we need to do is, you still trust me, what we need to do is we need to rewrite this in terms of m equals. Okay, so h of n means put n on the other side. So there's only one thing to do to get m equals, because the only thing on the side with m is that +1. So we can write m equals -2 n plus 6 minus 1. Now let's see if it makes me distribute. Now that I got a gray box, I'm feeling a little risky here. So see if I can just do that. Hey, look at that. I didn't even have to distribute and simplify and combine like terms. Okay. Oh no, I'm not messing this one up. The range is the y values, and this one is continuous. And so what is the lowest y value? -5. And what is the highest y value? 5. And all of the y coordinates of this function are in between -5 and 5. So that's what we're looking for. They both have, they include those points. And so we are going to put or equal to's, and y is the same thing as f of x. All right, Aiden is a taxi driver. And so m of n models his fee and nth drive. So his fee for his 8th drive, fee for 8th drive, is less than his fee for his 4th drive. His fee for his 8th drive earned less money for his 8th than he did for his 4th. Yeah, that's right. All right then. Well, Have a good time, and post your questions in the organizer. I'll see you in class.